All right, here's a couple of good questions. The student that sent this to me asked the appropriate question. And the question was, well, which one do I use? And that's what I sort of want to answer in this video. So I'll do two questions and see how we do. Okay, so it says, consider the reaction of magnesium metal. So magnesium plus hydrochloric acid, and it produces magnesium chloride plus hydrogen gas. Okay, and that would be aqueous. I think this would be aqueous, and this is a metal. Okay, let's balance it first. So I need a 2 there. I think everybody else is good. All right, so 1 to 1 to 1. So they say if I have 3.29 moles of magnesium, 3.29 moles, nice that they already converted it to moles for us, and I have this many moles of hydrochloric acid, they say how many liters or what volume of hydrogen gas is produced, and they tell us that the pressure, nice atmospheres, that's 101.325 kilopascals, and the temperature's 49. Okay, 273.15 plus whatever 49 is. Now, hopefully you can see in the question that they're giving us too much information. Usually they only give us information about one thing and ask for information about another. But this time they gave us information about two things and are asking about the other one. And so this is a classic question of a limiting reagent. So what you've got to do is figure out which one you don't have enough of, or you can figure out which one you have excess of. And the way I do it is I like just to take whichever one of these reactants, doesn't matter which one, and figure out how much of the other one I would need. And I do that just simply with mole ratio. So let me show you. So let's start with magnesium. So if I have 3.29 moles of magnesium, how many moles of HCl would I need? Okay, and I just do a simple mole ratio thing with that. So I have 3.29 moles of magnesium. So multiply it by the ratio, which is 2 to 1, right? So 2 moles HCl to 1 mole magnesium. Okay, if I multiply that, I'm going to come up with 6.58, I think, moles of HCl. Okay, so if I have this much magnesium, I'm going to need this much HCl to react it all. But how much do I have? But I only have, in the question, 3.29 moles of it. Therefore, since I don't have enough of the HCl will be my limiting reactant. But I only have 3.29 moles of HCl, so HCl limits the reaction. So, and again, the student asked the question and said, well, which one do I use? You use whichever one is going to limit the reaction. So the HCl is going to limit things, so I forget about this one. I did need to use it initially just to figure out which one I should use, but once I know which one is the limiting reactant, then that's the one I use. So in this reaction, if I was doing that in the eudiometer or whatever, and I had the acid come down on the magnesium, all of this magnesium would not react. Some of it would be left over because there's not enough acid to react all of it. Okay, so then we'd continue on with our stoichiometry. So solid, liquid, gas, moles. looks like I'm starting with moles. This side is my given side, and this will be HCl. And this will be my asked side, and that'll be the hydrogen gas. So I'm starting at moles, so I'm going to have to do a mole ratio. Although I've already done a mole ratio here, but I have to do a mole ratio to get to moles of hydrogen. So I can't just fall back on that one. I've got to do the right mole ratio. And then I've got gas information, so I'm going to be going down to gas. So two-stepper. So first, let's convert moles of HCl, that's my limiting reactant, to moles of hydrogen gas. So I have 3.29 moles of HCl. Notice I'm using this amount up here. I'm not using this one here. That one was there just to help me realize that I didn't have enough HCl to react with all the magnesium. So 3.2 moles of HCl times, okay, hydrogen is 1 mole hydrogen and 2 moles HCl. Okay, so when I multiply by 1 divided by 2, that's going to come out to 1, 6, 4, 5, I think, with a dot in there somewhere. Moles hydrogen. Okay. So that's step 1, and then now step 2 will be take the moles of hydrogen and also take the pressure and the temperature that are given and convert that into volume of hydrogen gas. And we'll use our PV equals nRT to do that. Looking for volume, so volume is equal to nRT over P. Moles, 1.645 moles. R is 8.314 kilopascal liters per Kelvin mole. Temperature, 49, right? 273 plus 49, 12, 1, 322.15 times 322.15 divided by the pressure was 101.325 kilopascals. Those cancel, the moles cancel, the kelvins cancel. Okay, let's see. Let's do this on my calculator. So 1.645, come on decimals, 1.645 times 8.314 times 322.15 divide 101.325. I'm getting 43.4827. So 3 sig figs probably. So 43.5 liters. Let's see what they have. Oh yeah, they have that as an answer. I'd pick that one. Let's try one more. Okay, consider that calcium metal reacts with oxygen in the air. Calcium metal reacts with oxygen gas, and it forms calcium oxide, so CaO. It's probably going to be a solid. You could confirm that. And calcium's 2 plus, oxygen's 2 minus, so they're even. Okay, so to balance, I need a 2 here. That gives me 2 oxygens, but 2 calciums, so I need 2 calciums. Good. Okay, so then they say, suppose we react 7.43 moles of calcium. 7.43 moles calcium with 4 moles of oxygen. Then they say how many moles of calcium are left over. Oh, how many moles of calcium are left over after the reaction's complete? Oh, I thought they were going to ask that question there. Well, I guess it could be none, or I guess it could be some. Interesting. Because that's a different limiting reagent kind of question. But determine the number of moles of calcium left over after the reaction is complete. All right, okay. Well, let's maybe start with the oxygen and do a mole ratio to see how much of this would be required if I used all the oxygen. So if I have 4 moles of oxygen, if I use a mole ratio, it would be 2 moles of calcium for every 1 mole of oxygen. So if I do that, that would require 8.00 moles of oxygen. No, of calcium, sorry. Because moles of oxygen cancel, would be moles of calcium. Oxygens cancel, calcium doesn't. So if I use up all my oxygen, then it would use up 8 moles of calcium. But I only have 7.43 moles of calcium. So all my calcium is going to get used up. Determine the number of moles of calcium left over? Yeah, none. Oh, right there. You're not going to have any calcium left over after the thing's done. That's just a quick little intro to limiting reagent. There'll be more questions, and I don't know about tougher, but ones that require a little bit more work, and we'll do some more of those next week.